Okay, wonderful. All right, so great to have all of you in this session. Please use the YouTube chat to ask questions. And if you have any questions, just feel free to post it on the YouTube channel. All right, all right. So I'll be taking the questions in this session. Okay, wonderful, wonderful to have all of you in this live stream. Hi everyone, are you able to hear me and see my screen clearly? Hi there, are you able to hear me and see my screen clearly? And I hope that you are able to see my video as well. Hi everybody. All right. All right, so wonderful to have all of you in this discussion. I'm hoping that you will be benefited by this session a lot. Great, great. Wonderful to have all of you in this discussion. All right, so we are about to get started, and if you have any questions, please feel free to ask using the chat. Welcome to a session on Introduction to AI and Machine Learning. As part of this discussion, what we are going to do is we are going to understand what is CloudxLab. Similarly, we will understand what exactly is machine learning, AI, deep learning, and also we will learn the various kinds of machine learning and the approach of machine learning. All right, so this session is going to be very informative for all of you, those who are new to machine learning. All right, so wonderful to have all of you in this discussion. Please feel free to ask questions using the YouTube comments or YouTube chat. All right. So great. I'm very happy to see so many users on the YouTube channel right now. Great. Hi, everybody. So let's get started. Okay, so let's get started. All right, so you must be hearing a lot about AI and machine learning. As part of this discussion, what we are going to do is we are going to understand the basics of AI and machine learning. And afterwards, you will be able to decide what course to take and where to proceed and so on. So I'm hoping that this is going to be an extremely important session for all. Those who do not know about CloudxLab, I'll walk you through what exactly is CloudxLab. Also, please note that we are running the free courses at CloudxLab. There are many free courses at CloudxLab, so feel free to enroll into those courses. Wonderful. All right, so welcome to an introduction to AI and machine learning. As part of this discussion, the main format is going to be, all right. So first we will go over what is CloudxLab, then we'll talk about the course, we'll talk about the speakers and the instructors, then we'll learn what exactly is machine learning, and then we will learn about machine learning approach and what exactly is AI. Afterwards, we'll have Q&As, and then we'll take 10 minutes break. And then we will talk about various kinds of machine learning. And then we will talk about the neural network. So we'll understand what exactly is neural network. And this is going to be very, very aggressive webinar, as in it is going to be around 3 hours. And we are going to focus a lot on the details. All right. So it's an open session for all on YouTube Live. The right, except for instructor, everybody is on mute by default, and questions can be asked using the YouTube Live chat. The recordings and slides will be shared with all of you after the session, so do not panic, but feel free to take screenshots or share with friends. It is completely okay to share the screenshots, as well as we'll be sharing the PDF of the slides, and the recordings as well will be available on the YouTube. All right, so the instructors and the author of this course is myself. I'm Sandeep Giri. I started my career long back, around 18 plus years back. I passed out from a college called IIT Roorkee. And from there, I joined a company called DE Shaw. At DE Shaw, we were processing humongous data, and we were applying machine learning techniques way before its time. And we were doing processing using around 10,000 nodes or 10,000 nodes of network, 10,000 computers in the network, essentially. And after DE Shaw, I founded a company called Tbits Global, and then I worked with InMobi and then Amazon. At InMobi, we built the recommendation engine, which is basically machine learning using petabytes of data. And not petabytes, it's around a few hundred terabytes. And then I joined Amazon. At Amazon, again, we did the real-time processing and a lot of work. The Amazon mobile app, especially the page on which you do buy now, is something that I owned at Amazon. After that, I started CloudxLab, and at CloudxLab, we basically are making the education more and more hands-on, more engaging, and more realistic. Okay, more real life. The whatever tech education we are providing is based on what is needed in the industry. It is not about completing the theoretical aspects. It is theoretical aspects plus the entire learning experience, the entire hands-on approach is what we are focusing on. No matter how much we teach you concepts, if you do not do hands-on, all of that work is not useful. All right. So as part of this, as part of as part of all of the courses at CloudxLab, we focus a lot on hands-on approaches. Now, the other person is Praveen. Praveen is also one of the instructor and author for the course. He has a wonderful experience in the technology industry. He has a master's as well as graduation from IIT Bombay. It's a dual degree. And then he worked with Cypress, Philips, and he has multiple patents and has published multiple papers. And he is CTO and co-founder at Yates, and he is also one of the co-founders, one of the co-authors of this course. We have Abhinav. Abhinav is the co-founder at CloudxLab. He has a wonderful experience with AI and machine learning and big data, and is also a faculty at SCMHRD, the adjunct faculty. And he has worked with Byju's and Hashcubes, and he has close to 9+ years of experience in education as well as gamification. So, and he's a hardcore engineer at heart and also enjoys teaching people. All right, so the main course that we are basically introducing today is the machine learning specialization. It is an online instructor-led training whereby we basically, it's a blended training in the sense that there's a lots of hands-on exercises in Cloud-based lab. And then there are lectures and there are discussions and so on. There are 18+ real world projects available on the CloudxLab. And these are guided projects in the sense that it would nudge you slowly and you will get the feedback immediately, and you will be able to build things, you will be able to build real-time systems by learning from the guided projects. So there's a verified certificate, and there's I mean, we basically have a good discussion forum and a discussion forum, as well as we have a very, very vibrant learners community. And we also provide the support over the email. All right. So basically, that's the machine learning specialization. This is actually one of the most deep dive courses available at these prices in across the globe. And I can guarantee that whatever you learn in this course is going to be life-changing for you. It will basically impact your career. It will basically improve your career beyond what you had imagined. All right, because it takes you from the beginner in machine learning till you become a machine learning engineer and understand everything end to end, including the complex concepts of reinforcement learning. All right. So basically, the course structure or the way you should be learning machine learning is that you start with foundations. And I would strongly recommend that you should go over Linux or Unix or command line. If you are on Windows, you can use Cygwin, because if you're planning to become a machine learning engineer, it is imperative that you should be very hands-on. And unless you become hands-on on your computer, your operating system, or the command line, it would not work out much, because command line helps you automate lots of data processing, automate lots of engineering, and therefore, I strongly recommend that you at least go through the free tutorial of Linux, which is available at CloudxLab. Further, in the foundations, you should learn Python. Python is useful in many aspects. Almost every company uses a programming language these days to solve various kinds of automation related problems, or building a mobile app, building a web app. All of these can basically require you to learn a programming language. So learning a programming language is something that you cannot escape in today's time. No matter which job you are in, I would strongly suggest learning a programming language. All right, be it Python, be it whatever you like, but it should be a programming language. It helps you thinking better. It helps you structuring your thoughts better. All right, so that is something that you should do. This again, Python course again is free at CloudxLab. You can just enroll. And of course, right now there are all courses who are running free, but in future, the Python course and Linux course are going to be free on CloudxLab. Then learn the data analytics or data pre-processing, or we call it cleaning, because when you get the data, right, 95% of your work will go in cleaning the data. Okay, and therefore that's exactly where you would need the understanding of data cleaning. After that, once you are, this part is foundations, and after foundations you should learn core machine learning, like get started in machine learning, like basic concepts of machine learning, and understand how to build a machine learning project. And I'm going to go into more details into this curriculum. And then you emerge into classic machine learning, and then deep learning, and then deep dive into deep learning. All right, so this is like a general structure. Even if you do not attend this course, I would recommend that you should follow this flow. Okay, this flow is basically to learn machine learning as well as deep learning together. And this is the right learning curve. If you are happy with up to here, like you're good with Python, then you can just start from here. Okay, so, and if you are good with, say, classic machine learning, you can start from here. So no matter what source of content or wherever you're learning from, your learning should be in this flow. All right, so, and all of this is available as of now at CloudxLab for free. You can enroll there. In the machine learning specialization, it's an online instructor-led training, whereby instructor would guide you from time to time and will help you solving your questions, making you understand every idea. And there are few seats left in the course, and if you are interested, you can enroll in that. The previous batch is full, and you can enroll at CloudxLab. All right, at CloudxLab, we are making learning fun and for life. There are videos, there are quizzes, there are hands-on, and there are projects. There are case studies, and so on. All right, so these two parts are very unique about us. The hands-on projects are something very unique about us, because this is why many people actually use CloudxLab. So why it is unique? Like, take a look at this particular environment. On the left-hand side is the theory, right? On the right-hand side is the playground. Okay, in the playground, you will have to code what the left-hand side is asking you. Here you can see that it's asking you to assign CloudX to first and lab to second variable. And once you do that and press Shift Enter, it'll basically, and then you submit answer, it'll say that you have done good job. Otherwise, it'll throw an error. All right. This way, the playground gives you instantaneous feedback and helps you learn incrementally, and it nudges you throughout the journey. All right. So almost every project at CloudxLab is in the form of automatic evaluation. Okay. Of course, we do review your project manually as well, but when we do the evaluation at later on, couple of days later, you do not really get instantaneous feedback, and that basically hampers your learning. So the way we have designed system is that at every point of time, you will be guided throughout. Okay, you'll be guided throughout, and this would make you learn things really well. Okay, we are seeing tremendous outcome from our assisted projects or guided projects. We are seeing that most of the people who are completing the guided projects are able to do pretty well in their jobs. They are able to solve problems and so on. And that's the reason why we have completely moved our focus to creating really, really good guided projects. Okay, so the other thing is the cloud-based lab that you hear over and over. We are a company which basically specialize in cloud-based lab, and the cloud-based lab provides you this entire environment on the cloud. Whether you are in office, you are at home, you can you can resume your work where you left. You can resume your study where you left. And this gives you access to all the tools, not only machine learning tools, but also big data tools. It also gives you analytics tools. It also gives you other web application related tools. And it gives you the complete environment where you can do lots of work. All right. And this gives you a freedom. This gives you a freedom to experiment. You have the data storage available for you in the Linux as well as in the Hadoop. All right. So Hadoop, Spark, Kafka, NoSQL, and all the entire ecosystem is available for you. All right. So this makes all our learners really, really powerful. They feel great about experimenting with the tools. All right, and we see this all the time that people start merging technologies. Like some people try to, after applying the machine learning, they start processing the data on big data, maybe big data frameworks such as Spark, and that magic happens because of the environment. All right, so this basically gives you a real world experience, as well as it's a seamless experience, nothing to download, and it can be connected from anywhere. Right. The next thing is the free guided project. I want to show you this part because this is something I'm very excited about, and we're working to make it more and more, the unique experience, one of the best in the world. I can guarantee that part. So this is where you will basically start learning by the way of projects. So these are the various projects. Like for example, here in this project, you have to forecast the bike rentals. Now, if you start this project, it will basically, right, you can just start immediately. All right. So you can see that on the left-hand side is the problem description. On the right-hand side is your environment that's coming up. Okay. And here you see that there's a lot of discussion that keeps on going, and our people keep on responding, and other users keep on responding. So you can basically get almost instantaneous feedback. All right. And here, basically, you can see there are 38 such pages, and it is essentially going to guide you throughout the project. Okay. So this essentially is telling that these are the various steps that we'll be doing as part of this project. And then it'll basically guide you and also make you do things like, for example, it's asking you to import this as NumPy and so on. So these things you have to do on the right-hand side. All right. So this is, this is something that we are really, really happy and excited that, I mean, this is a very successful way of learning. And this is very successful way of learning because it is very outcome based. It is something that will remain with you. You might forget the theory that I'm teaching, but what you do in the lab is something that will remain with you. Okay? Like you do not forget how to ride bicycle, or you do not forget how to swim. In the same way, if you do the hands-on in the lab, you're not going to forget those concepts. All right? So the guided projects are something that we are very excited about. And other than that, what we have done at CloudxLab that would really help you learn and connect is basically, it will help you build your social profile. Like here, this is Abhinav's profile. It has the number of XP points. XP points are representative of how proactive are you, how hands-on are you. Every time you are solving a problem, you keep on getting these points. And this is visible on your profile so that the people from all over can connect with you. And thus, it helps you improve your career. It helps you improve your career, not only limited to teaching. Okay, so it basically, there's a discussion forum and people keep on discussing here. There are lots and lots of feedbacks that we get, as well as you get this community, amazing community of users who you can connect with. You can send messages to them, and you can also upvote or downvote their comments or answers. And this way, when somebody upvotes somebody's answer, they get points, and that helps them help people build their public profile. We have created a jobs portal whereby various jobs get posted, and if you apply for any of these jobs, you can connect with the people who are providing these jobs. Right now, this is something unique that is going on right now. So we decided that in January, we will give all our courses for free, except for instructor-led training as well and lab. Lab is free for 7 days, and that you can just have to do KYC. And KYC is essentially know your customer, because since we are providing the entire environment, there is a chance of people misusing it. Therefore, we just take $1 of payment that gets refunded in a minute's time, and then you get the access to the lab. All right. So feel free to sign up for the free course as well as sign up for the free lab. That will help you improve your career. All right. And as I said, that when you are starting here, you start with Linux, then Python, then the other parts. Okay. So I would strongly suggest that you utilize. Still, there are 21 days left for the free Jan offer. So do not miss this chance. All right, so that's pretty much about CloudxLab. Let's get started with what exactly is machine learning. All right, so what exactly is machine learning? Machine learning is basically giving this ability to computers to learn from the data. Instead of explicitly writing code, we give the ability to the computers to learn from the data rather than from the instructions. Okay, so we basically give the data like experiences to the computer, and computer learns from those instead of you explicitly writing the code. All right, I'm going to go into more details now. All right, now, so has anybody played Mario? Have you played Mario before? All right, all right. Looks like many people have played Mario. Great. So you must have taken a long time to win the princess, right? And it must have taken. Can you believe that the computer can also learn to play Mario? Okay. We will only hook the computer or the program, we call that agent. We will hook the computer to the simulation of Mario, or emulation as they call it, and let the computer program keep on pressing the arrow keys and learn from the observations. We'll only tell it that this is the place on the screen that displays the score, and so on. Okay, so basically that would be the main idea. So long back, Tom Seven, this person, basically coded it, and it worked pretty well. It worked pretty well. So let's take a look at this particular example. Though it's a bit old, and but it is still very relevant in explaining what exactly is machine learning. On the day zero, it's going nowhere and is pressing the keys randomly and dies of old age. You can see that, right? So after a few more training loops or few more weeks of training, this is not few more weeks, few days of training, it is able to move forward, see a few frames in future, and is able to, at least jump. No reason why it's facing the backward, doesn't matter. Few more weeks, and it seems to be doing really well. Now you can see that it has become really, really good at it. And it has built this intuition about things that here I can jump and so on. Okay, so you can see that it is having no problems at all. I think it is stuck. Do you think it's stuck? All right, so it figured out that it can jump over it. So Mario is not having a problem at all, or the program is not having a problem at all. Now, few more weeks, it is expert now. The program, the agent is expert at playing Mario, and you will see something amazing right now. The something amazing is essentially this. What was that? Pay attention. Goomba is falling on it, and the moment Goomba is falling, it just starts moving downwards, and it fools the computer, it fools the Mario game into thinking that it jumped on Goomba while Goomba jumped on it. All right, so you will see this. I have no idea how did it do that, right? Now, similarly, when it is hooked to other programs and it is stuck, it just pauses the game. It just pauses the game, all right? Because it realizes the only way to keep the score is by pausing, right? It is like childhood when our cousins or siblings who are losing in a game, they'll just spoil the board and then run away. So exactly the same way, it starts pausing. So it is a sign of intelligence. Okay, so you can see that this is machine learning, right? The kind of bugs it exploited, the kind of bugs this program exploited in the game is something that we never knew, something that we never imagined, right? And this is something very amazing that computer is able to learn something that we have not known. Had we coded it, we would basically code it only the rules that we know. Okay, so it'll be as smart as we are or lesser than what we are, right? And therefore it won't be smarter than us, right? And this is exactly where machine learning comes into play. This is an example of machine learning whereby our program or software learns to build logic, learns to understand its circumstances based on the data, based on the data. That is the main idea in the machine learning, as opposed to somebody coding or writing instructions exactly how to think. Instead, show the experiences to the computer and let the computer figure out how to think. Okay, so this is machine learning. Question is, to make this program learn any other games, such as Pac-Man, do we need to write new rules as per the game, or just hook it to the new game or let it play for a while? Yes? Yes? Right. So basically, just hook it to a new game and let it play for a while, right? So essentially, the idea is that learn, let the program learn from the experience. Okay? Now, imagine doing the same thing for life. Imagine doing the same thing for life. And the main idea is that gather the data and solve the problems automatically. And that's the main crux behind the machine learning. That can we, the way human, it observes the environment, like I observe the environment, and I try to come up with, the next step, what to speak, which way to walk, which way to look, and what actions to take. All of that is essentially based on the data provided in this environment. And this is exactly the role of machine learning, right? So now, if you think carefully, I mean, one of the questions that everybody asks, like, why is machine learning so important? Because if you look at every industry, if you look at every industry is trying to predict. Every industry is trying to predict. Like, for example, manufacturing industry is trying to predict what to produce, right? What products to manufacture, how much to manufacture, at what price to sell it, and what is the process to manufacture, how to predict the steps that will improve the cost, or decrease the cost of production and improve the quality of product. So essentially, at every step, we are trying to predict something based on the data, based on the past. Similarly, agriculture industry is trying to predict. It's trying to predict which crops to grow, what should be the prices of the product or the produce, and what kind of process to follow. So we are trying to predict the prices, the crops, the process to follow, and so on. So many other things, like further, if you think about it, what insecticides to use, what kind of seeds to use, and so on. If you think about it, agriculture is essentially predicting various things. And if you break down the entire problem into smaller part, like which process to follow, then to follow each process, we will again have to predict the next step, right? Similarly, healthcare is trying to predict many things, like the disease. What is the disease based on the symptoms? Which drugs are effective? How can the pandemic be stopped? Which operating procedure is most effective? So if you think carefully that we are predicting for survival. So every industry is trying to predict. And and basically, thanks to the recent innovations in the field of deep learning and machine learning, I'm going to define what exactly is deep learning very soon. So every industry is trying to predict. And because of the recent innovations in the field of machine learning, these days there is virtually a tsunami in this field. Almost every problem has become a machine learning problem. And because this has yielded results, people are using the machine learning to build the AI, but they are using machine learning to build the self-driving cars, building the recommendations. It's not only the obvious use cases of machine learning that you see. It is not only those classic use cases. There are many use cases like predicting the price of a product in an e-commerce industry. Similarly, predicting the load on given day on an e-commerce website. At Amazon, we did this all the time, right? And similarly, predicting the product that the user might like. That's recommendation. Product recommendation at Amazon are a great example how data could be converted into sales pipeline, right? So we realized that at Amazon, the sales dramatically increased when we showed them the recommendations prepared based on the data. All right. So there are many use cases of machine learning. Basically in machine learning, we are saying that given the data, can we predict something, right? Similarly, like for example, Google wants to improve the search results, and they can basically look at the history and see that this person used this the people from this geography and these particular parameters like this particular results more than the other, and based on that they can order these search results using the historical data. Speech recognition was basically rule based earlier, but today speech recognition is essentially based on machine learning. Based on the data, the machine learned how to recognize speech. Now, when we say predict, there are two parts to it. Number one, the data, the underlying data. And second is intelligence, right? Gather data, apply algorithm, and predict the next step, right? That's the main idea. So to solve automatically any problem, we need these two aspects. Gathering data further involves collecting data, meaning building the storage, building the transfer mechanism, then cleaning data, as in splitting data up, storing it, and formatting it, and so on, and further processing it, as in applying all kinds of inference on it, right? The this data, to collect the data, the first part of this, to collect the data, as of today, there is a huge innovation in the phones and devices. As of today, the hardware has become really, really cheap and powerful. Cheap and powerful. And every device has become smaller, cheaper, and faster. And that led to this, this tsunami or this revolution whereby storing enormous amount of data or transferring or gathering enormous amount of data has become easy. Your phone has way more sensors than any other device in the history, right? So your phone is a big data generation device. Similarly, there are hundreds of other hardware today. Hardware is really, really cheap. In like, you know, in couple of dollars, you can buy a processor and like bundle up the entire sensors. So that's a this is an amazing part of today's time, that on one hand, the devices have become cheaper, smaller, and faster. On the other hand, the connectivity has become really, really omnipresent. Like there is Wi-Fi, 4G, NFC, Bluetooth, GPS, and so on. So by the combination of connectivity and the hardware devices, we are able to collect data. You will be able to collect data, right? Now, when you have humongous data, once you have collected data using the devices and using various kinds of connectivity, the next thing is how do we process petabytes of data? This is where the distributed computing, or we call it big data engineering, comes into play. This is a big revolution, right? When you have terabytes of data or hundreds of terabytes of data, petabytes of data, it's impossible to process it using any single computer, because the computer is not a problem. The problem is the read speed of the devices, the rate at which you can read this data. So one of the biggest revolution happened in the recent time is to be able to process data parallelly using thousands of computers. All right. This made it possible to clean petabytes of data in a reasonable amount of time, and to do the processing using many computers rather than one computer. And this is usually achieved using frameworks such as Hadoop and Spark. And those who basically use hundreds or thousands of computers parallelly, they usually use Hadoop and a Spark stack for processing that. Right? So this was the phase we collect the data, process the data in a humongous way. Once we have clean data over which we can train, we can apply various kinds of algorithm. So data and intelligence using big data techniques, sensors, and various kinds of connectivity way, we gathered the data. Now we got the data, we cleaned it using a big distributed system like big data engineering, Hadoop and Spark, and there are many more such systems. And using many computers, we processed our humongous data. Now we are left with clean, perfect data. Then we can apply the machine learning or intelligence on top of it. All right. So now is the time to understand this intelligence part of it, or machine learning part of it. So let's take an example of the approach. So I'm going to help you understand the difference between classic approach and the new approach, right? So you must be using email systems. I'm assuming that all of us are using email systems, right? And let's take a very simple task of creating a spam filter. It's not, of course, simple. It's actually complex. So when we are building spam filter, what are the things that we need to do? All right. In the classic approach, what we will do is we will study the problem. We will study the problem, right, ourselves. And here we will study the problem, and then we will write the rules. We will ourselves code the rules, like if the subject is this, if the subject contains this particular word, or body contains this particular word, let's mark it spam. Otherwise, mark it not so spam, or we call it ham, right? So spam filter can be built using this traditional approach, whereby we are writing rules, right? We are writing the if-else conditions. We are writing this logic ourselves, okay? So the understanding of the matter is dependent on the programmer. They will observe, go through all the emails, look at all the emails and see which emails are spam, which is not spam, then come up with the logic that, okay, if the subject line contains this, mark it as spam. If the email is coming from the domains like this, mark it as spam. Otherwise, it's not a spam, right? Now, we evaluate this kind of model. So we will write like thousands of such rules. We'll write thousands of such rules, and we evaluate it. And then if it's working perfectly on unseen data, we will basically launch. Otherwise, we'll go back to the analysis. We'll go back to analyze errors and so on, right? Now, these are the kind of rules that you'll be writing, that if the email subject contains credit card, free, amazing, most likely it's a spam, right? If the sender's email is abc@xyz.com or webmaster@mysite.com, it might be a spam, right? Now, this is the traditional approach, okay? Writing rules is the responsibility of human. Writing rules is the responsibility of people. Now, this is efficient in the cases where we do not have any historical data, right? Now, so when incoming emails come, it goes through the thousands of rules, and using those rules, it'll basically classify the email into ham or spam. Now, do you see any problems with this approach? Is there any problem with this approach? Yes. The traditional approach, the one that I just talked about, do you see any problems? All right. Yes, there are many problems in this approach, the traditional one. And the first reason is that in the traditional approach, that's correct. In the traditional approach, the rules will keep on piling up. Yes, exactly. We do not know all the rules, right? So one of the chat answer is that we do not know all the rules, right? And second is the large code and set of rules, exactly. So we'll have these bundle of rules, and it depends on how much we understand about the rules. And basically, the other problem is that imagine that the spammers know about your rules, and they realize that whenever we are using amazing, it's going in the spam. Therefore, they will start using a word fantastic. And, and therefore, this will be a never-ending loop. Okay, this will be a never-ending loop. Now, if you have to build the same system using machine learning approach, how would it look like? Right? So we'll basically study the problem, train the machine learning algorithm. We'll study the problem, train the machine learning algorithm based on the data, and we will evaluate the result based on certain data that our model has not seen before. Okay? And then we will evaluate whether the rules that machine learning algorithms came up with are working or not. So this is our training phase. We basically feed the data to the algorithm. And then we basically evaluate our model on the data that is not this, that is separate from this, because our algorithm has seen this data, and then we evaluate it and then see whether it makes sense or not. If it is making sense, we will launch. Otherwise, we go back to analyzing error and then start feeding the data or retraining our model. Okay, so this is machine learning approach. All right. The more important part is here, writing rules by programmers is replaced with training machine learning algorithm. Showing it over and over that this email is spam, this email is ham, and so on. So we'll keep on feeding that data over and over to the algorithm. And algorithm will basically learn by this data to predict whether it's a spam or not a spam, right? And this is something that is great. Now, in this case, all you have to do is convert the emails into a tabular form such that Each row represents one email, and each column represents the feature of an email. Okay, so okay. All right. So basically, that's the main idea. That's the main idea. Now, moving ahead. So essentially, the machine learning approach, figuring out the figuring out the data, figuring out the rules based on the data is the responsibility of the algorithm. We only structure the data that the algorithm can understand. We convert every data into numbers and we feed this to the machine learning algorithm. All right. So that the process of converting any data set into the the numbers or a table format containing numbers is something that is the role played by engineers. That's the role played by data scientists. That's the role played by machine learning engineers, and so on. So essentially, this part where we are studying the problem, converting the raw data into certain feature sets or characteristics or tabular format containing the numbers, that process is done by the people like you who are going to be the target audience for this course. All right. Okay. So if you have any questions, you can ask. All right. Wonderful. Okay. Great. Wonderful, wonderful audience. I'm really enjoying, right? We have so many users right now and online attending this. This is great, great to see so enthusiastic audience. Wonderful, wonderful. All right. From here, Praveen will take it forth. So Praveen will be starting the discussion now. Okay. And yeah. So there's a question before Praveen takes over. There's a question that I want to answer. Question is from Nimai. Nimai, can a fresher get a job in data science field? Yes. So that's an important question. And the quick answer is today, the machine learning or data science field has many, many, many roles to play. There are many kind of jobs. There is a data engineer job, there is a data scientist job, there's a machine learning engineer job. There are many kinds of jobs. So in my experience, most of my learners, in spite of being freshmen, they're able to get a job in the field in this field. Even if not in this field, they got the job as software development engineers because they knew more than an average software engineer, and they knew machine learning because even as of today, the machine learning understanding is expected out of the engineers. Okay, so yes, it does help you get a job. It does help you, right? So the other part is like data cleaning job is like 95% of the job of engineer is data cleaning. right? So if you learn machine learning, by the way I've explained, you are going to be good at data cleaning, and no matter whether you're fresher, very experienced, you will be able to do that. And once you have cleaned the data, you can apply machine learning. So earlier there was a mental block that people had, that, oh, only PhDs would enter, right? Similar to what was there earlier in 80s. There was a thought that like very, very sharp people, or very, very, right, those people from that big institutions will only be able to code, and there's a lot of maths required and so on. In the 80s, that was the thought. But today, everybody can code. Today, similarly, the machine learning part, right? I mean, few people think that machine learning is only for PhDs and so on, but no. If you see today, almost every company is training their engineers, their freshmen, they're hiring people who know about machine learning and data science. And that's the reason why being a fresher, being in non-computing field, being in software development field, and so on, you must learn machine learning. Because even if you are a software development engineer building mobile app or web app, if you have to deploy a model or optimize the performance of a model, you will have to know what is going on in machine learning, right? So I've seen that most of the software development engineers, most of the people who are coming from the testing background, they are getting benefited by understanding how machine learning works, how to use various techniques, understanding how do we say that an algorithm is working fine, algorithm not working fine, and so on. So no matter which field you are in, if you are interested in machine learning, or my suggestion is that you should be interested in machine learning, because this is going to be the part in every vertical of human sciences, right? The purpose of science, purpose of maths is to be able to solve life, and machine learning can help you. If you have data, even if you do not have data, you can gather the data, or you can use a pre-trained model to solve your problem. So this is the best time to get yourself upskilled in the machine learning. And right, and even if you have not known programming earlier, you can start today. Almost everything is available, every resource is available online, and this is the best time. Okay, so over to you, Praveen.
Hey, Thamsandi, thank you. A great lecture. I'm going to take over the baton now. Uh, let me start sharing my screen. So I'm going to stop sharing your screen, Sandeep.
Okay.
And I am going to start sharing mine. Tab. Okay, it's lots of things that are open. Okay. Okay, folks, I think you can see. Okay, so what we're going to do is, so I see a lot of people have just come in recently, and okay, let my screen just start. Okay, I'm going to start. What I'm going to do is I will do a little recap of what we did for the benefit of the people who've just joined. And for the people who have been going through, if they want, they can take a 10-minute break and come back. If you want a water break or a dinner break, etc., whatever break you want, you could go and have it. I would take about 10 minutes to do a recap, and we'd still be here for the people who just come in and would want to know what we did before. We will do that quickly. Okay, so I'm the guy in the middle. Uh, and I'm an instructor in this course, in the machine learning course, which is what we spoke about. So the machine learning course is a great course. We go start from the basics. So like from Linux and Python, etc. We go all the way to reinforcement learning by touching on, at the same time, we touch concepts like new NLP, computer vision, etc. So one of the so the people who are interested in going to this course, you can go sign up for the course. So the course structure is that the first part of it is based on the foundations, which is Linux, Unix, Python, etc. For the people who are not familiar with it, it's a great way to do it. Even in case you have experience with Linux and Python, it's a nice exercise to get a refresh of whatever you've learned. The After that, what we do is we go talk about pandas and numpy, which is so big part of data or machine learning, etc. is actually data pre-processing, and that's going to be covered in this part of the component or this part of the course. Then we slowly go into machine learning. We understand what the basics of machine learning, how to build a machine learning project. Then we talk about classical machine learning, which is decision tree, naive bayes, ensemble. Then we go towards deep learning, the really new things, where we talk about artificial neural networks. We go into deeper and like really applying artificial neural networks to solve real problems of today, like using CNNs for computer vision, NLP with RNNs. Then we do reinforcement training, creating images and artwork with GANs, etc. We do all that. Very importantly, what CloudxLab has is something called projects, hands-on projects. Okay, this is the machine learning course, more of it. So basically what CloudxLab, it makes, there's a lot of videos, quizzes, hands-on projects, etc. that give you a wholesome experience of learning. It's got the hands-on, there's got a nice way where you can write in code and you can get feedback immediately. So you're not really waiting for somebody to take a look at what you're doing. You can do this at any given time from anywhere. You have a nice environment, typical environment which you would start it in any big company. If you join a company, you would typically get an environment pre-built for you to do it. So you don't have to spend too much time setting things up. And from day one, you can get started with your course. Okay. So there are some questions that are coming in, and I'm going to answer them also as this goes in. Okay, so there's a question from Mohammed. How can I use ML in case and control study? So machine learning. So as you go in deeper, what you'll understand is that typically, if you're using something like supervised machine learning and what you need to do is you need to give some sort of data that's ready already, and you can. So what we're gonna cover is the idea of it, and then that needs to be applied. Okay. The next question is Lakshmi is asked how the data is trained. We will give you some. We'll talk about it a little later. Okay. So there are lots of questions of how we're going to train data. I think we'll talk about that a little later. That's all right. So there's a question from Ravindra Kumar. Is the algorithm needed to write or is it already built? So Ravindra, there's a lot of algorithms that are already pre-built, which you can use and get started with already. Sometimes you can create your own. So I wouldn't use the word algorithm. I would instead use the word model. I think that's a more appropriate model when you talk machine learning. So there are a lot of models that are already available for you, which you can use directly. And you do, and yes, and if you come up with something new, then you would want to build your own model for that particular exercises. Okay, that is one classic question: is how much math is required for learning machine learning? So I'll tell you again, not much. You would have to do basic differentiation. So from BODMAS, you can do, if you know BODMAS, that's brackets, off, division, multiplication, addition, subtraction. You can understand the basic mathematics required for machine learning, the basic mathematics, okay? And with that, you can get started. I think Sandeep also spoke about that. Initially, there was a lot of people believe that you need an advanced degrees, you need postdoctoral studies to do machine learning. That is not true. To actually do machine learning, you just need to have a basic idea of mathematics, and you need to get a basic idea of how data gets modeled. And once you do that, you can get started with it. Okay, there's a question from Nimish Gupta. What are the prerequisites for the ML course? There aren't too many prerequisites. Preferably, we would recommend that you know you have a background in mathematics. Some, at least you've done 12th standard mathematics or 12th grade mathematics, high school level mathematics, and you have some experience with a programming language. If you don't have much experience with programming language, so we actually have, I'm going to come again. So what I recommend is that you can get started with the course right now and start going through the foundation courses. So a lot of this course material is self. There's a lot of, we provide a lot of videos and projects. So if you are a complete, as like if you don't have much experience with Linux, then what you could do is you could get started with understanding Unix, Linux, and Python, and just follow the course as it goes. Like this is the water flow that we recommend. And if you do this, you can get into machine learning from wherever you are. Okay. So, okay. So this was about the machine learning course. This is about CloudxLab. I'm just going to go through it. This is the project. Okay. So what I was going to say is that what I'm doing is essentially I am doing a recap. And I'm just going to get back to this. Second. Yeah, so what we so we're doing a recap for now. We just saw this. Okay, then this was something which was very unique about CloudxLab, the free guided projects. There are a lot of, so the really unique thing about CloudxLab is that it gives you a lot of projects which you can work on hands-on. We've got about 30 plus project as of right now online for you guys to work. And just increasing. We add almost 2 to 3 projects a week. These projects go all the way from Git, so control concepts like Git, what's called document control, to machine learning. You have projects on computer vision. You have projects on sequence processing. We have projects on even GANs, etc. We even have projects on reinforcement learning. So I really recommend that you take a look at the projects. You can actually go through those projects for free, take a look at it. And this is something which anybody is doing. You should do projects. That's that's the best way to learn to do real problems using the project system in CloudxLab. Okay. So, okay, there's a question from Saurabh Mishra. Should we go through the foundation courses before, like Python or Linux, or will that be covered? So that is already, Saurabh Mishra, that is already covered in the course. So what I recommend that you get started on it early on, as soon as possible. So you just get started and you can start looking at it right now. Okay, so that's what we recommend. Okay, so the nice thing about this is the CloudxLab has a nice, strong social platform that enables interaction. It also enables people to see where they are. There are leaderboards. There are a lot of ways in which you can interact with the instructors, the teaching assistants, and fellow students to solve. So what we try to do is we try to re-simulate a real classroom experience for you. Okay. Okay, we have a job portal for the guys. So, and then we have a lot of hiring partners who hire directly from us. And we have this attractive offer called No Pay Jan, where you can go sign up for the courses. You get all the courses except for the instructor-led training courses. Everything is free. There is the labs are not available, but you can buy the lab separately. The lab really isn't much. So for people who want to figure out or starting out, you could just explore the courses and try to learn it for free. You can take the lab to understand how the lab works. Initially, the lab is free, so you could go ahead. Sonam Doji asks, how long will it take to become an ML expert? Sonam, it really depends upon how much time you spend on it. Okay, so it really depends on how much time you spend on it. But I would say you can actually start solving basic machine learning problems within actually in a few months of starting the course. So like actually, if you finish the first few chapters of the machine learning component, you can actually start solving basic machine learning problems. So it depends upon how far you want to go. So I would say within like a few months into the course, after you finish the basic end-to-end exercise, you would have no basic. You would know enough machine learning to actually solve problems. Okay, but machine learning is a very huge field, and so we cover a lot more than that. But you can get started really, really fast. There's a question: do we cover PCA in machine learning? Yes, we do cover PCA in machine learning. That's a part of the. It's in our dimensionality reduction exercise. You would have it. So we talk about what is machine learning, and then we went through a little recap where we showed how you could, how Mario learned to play the game. I won't show that again. And the whole idea is that once you once you have a program that can observe and learn by itself, that program then can be applied on just a different game like Pac-Man, etc. And you don't have to retrain or you don't have to teach or you don't have to do fresh programming. That's the right thing. You don't have to do fresh programming if there's a new game. The program would just take a look at it and would try a few things and would figure out automatically. So that's the idea of machine learning. Okay, and the whole idea is that why is machine learning getting very popular is that fundamentally all the industries, what they're trying to do is they're trying to predict. And the way you try to predict is that you look at previous data and then you try to understand how to do it. So there's a lot of questions of how this works is that what we got is what we have is you get previous data. So for example, you could have, you could just have, you could say that there's I think there are a few exercises later, we will get that a little more clearer. Okay, so there is the manufacturing industry that's trying to predict, agriculture is trying to predict, healthcare is trying to predict. So what predominantly happens is that you try to look at existing data and you try to match it to existing outcomes, to what you know already. Okay, that is one of the classical ways of machine learning, and you train a model to do that. Okay, we'll discuss that more and more. Okay, and so we discussed how it's being used everywhere from self-driving cars to OTT platforms to e-commerce, Google research. If you have then you have well, what you do is basically put data in intelligence, and what you do is you have to collect data, clean data, and then process it. Then one of the reasons why things are really getting popular is that there's just lots of data available because hardware has become very cheap and there's a lot of connectivity available. So it's possible to collect a lot of data and store it. That makes it possible to get large amounts of data together and process it. Then we went through a nice example of what's called where we compared where we made a spam filter with a traditional approach, that's rules-based programming, and the second with the more modern method, which would basically take a lot of data. So what you would do is you would take a lot of data and you would train it. Okay, so somebody says, hey, how does that happen? So I'll just give you a simple example. I won't take the whole thing, but I'll take a simple example. Say you have so for example, if you're plotting something like, hey, say price of an old car. Okay, so you have price of an old car, and you have the age of the car. Okay, I'm just giving you a simple example, age of a car. Okay, so typically, so what will happen is that you would notice that you have pieces. I'm just trying to oversimplify the problem, okay, and I'm just trying to tell you how machine learning works. So what you would have is that you would have some amounts of previous data. You would have saying that, okay, for a car that is like 1 year old, the price is higher, and as this is like a standard thing you would know, and as it gets older, the price keeps going down, right? So you would have points like these, okay. You basically would have, say, a lot of points like these. Understood? So So this is how classical machine. So what happens is that when you then do what's called training, so this is the existing data you have from whatever existing cases. What you will do is you will build a model. And when you build a model, you say, okay, I have this line like this. It kind of predicts results reasonably well. And now this straight line, what you have, becomes a model. Okay, so next time when you're given a price of a age of a car, what you would do is you just put it on this line and see, okay, what is the age? The age comes over here. Okay, so the age is over here, and the price is over here. So that's how you would do machine learning. You would take existing data, you would try to find some sort of a model that fits this and does this. Now, so what we try to do, the same thing, we try to do something similar with large amounts of data over here with a very complicated model. Okay, so so here the large amounts of data are lots of different types of emails, which are clearly marked as spam and not spam. And then you would basically have a model which would not be as simple as this, would be a lot complicated, would have several dimensions, etc. And that model you would run the data and the model would figure some relationship out. And once that relationship is figured out, you would then launch it. That is how this works. Okay, fine. So now what we'll do is we'll clear all my drawings, we'll close to the, and let's continue. So okay, so this is me, and I'm going to just start here. As you said, we just wrapped up we've wrapped up the session, we've wrapped up Sandeep's session, and we'll take about. So what is AI? AI is the theory and development of computer systems that perform tasks that usually require human intelligence, like visual perception, speech recognition, decision making, and translation between languages. Okay. So historically, we've been obsessed about creating machines that are similar to this. So if you go to prehistory, the Greeks had this mythology of Talos, who was a large bronze man. They have a myth about that. More recently, or not recently, say in the 18th century, you have Mary Shelley's Frankenstein, which was again about a created human being. So we've been always fascinated with the idea of creating things that can behave like human. With the movies like today, it's a lot more common, and every alternate science fiction movie discusses this. So the term artificial intelligence was coined by John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester. Okay, so what they did is that they specified what are the sub-objectives of AI. So they said that, okay, these are sub-objectives of AI. They said it's perception, reasoning, ability to navigate, ability to do natural language processing, and ability to represent knowledge. So these days defined as sub-objectives of AI, and essentially that if you can achieve these sub-objectives, you have achieved artificial intelligence. So one example of reasoning, what is reasoning? Capability to play a puzzle game like chess, Go, Mario, prove a geometric theorem, diagnose diseases. Then there's a question of how to plan and navigate in the real world. This is about navigation, a very important problem today with self-driving cars, etc. So how do you locate a destination, how to pick a path, how to pick the shortest path, how to avoid obstacles, and how to move. So these are issues that you would have to resolve while creating a navigation system. The other thing is about natural language processing, is how to speak a natural language, how to speak a normal language, how to understand a language, how to make sense of a sentence. We see a lot of it today in our phones, if in the home applications, Alexa, Siri's, OK Googles, that all are capable of doing it today. So we're seeing a lot of it. So perception is a very important thing. It's a very human thing, a thing which a small baby could do very easily, but computers really do have to do a lot of work to do very simple things which humans could do very easily. So the art of perception is how to perceive a real world from using sound, sight, touch, and smell. And so what the concept of generalized intelligence, this was what they initially hypothesized, is that if you get the basic building blocks, from that would emerge the second set. The what's generalized intelligence, like emotional intelligence, creativity, reasoning, and intuition. This is what the initial folks thought about. Okay, so another way of looking at AI entire system is that so AI is an end objectives, and what it does, it takes hardware and software to achieve it. So on one end you have hardware, which would be robots, IoT sensors, maybe your mobile phone, and on the other side you have software. And as you notice, there are different types of software. You could have simple rule-based programming, like the kind of example we saw with traditional spam filter, which was just rule-based programming. But that's also AI in a simple way. And there's machine learning, and then there is deep learning, which is a small component of machine learning. And we will go through and understand the differences of that. Okay, so now what are machine learning types? So machine learning types, so machine learning at its basic can be resolved into two types. One that's done with human supervision, ones that can be learned incrementally, and how do they generalize. So these are three types that you can say started at. Let's look at human supervision. Okay, so we have supervised, what we call supervised learning. So what is supervised learning? So whether they're supervised or not, so whether a model are trained with human supervision. What does that mean? What does human supervision mean? Uh, so, so in human supervision also has two types. One is classification and regression. We'll just see what that types is. So in classification, what we do is that we would have to give that training algorithm, which we said, a set of solutions. So you would have to give what's called label data. So you also have to say, okay, these are my inputs, and for these inputs, these are my outputs. So in case of a spam filter, so a spam filter, the input would be the address, the receiver, the from the sendee of it, the receiver of it, the IP address, the subject, and some amounts of content of that email. That would be like that would be the input, and then there would be label. A label in the case of a spam filter, just two. That's spam and ham. Just two. That's labels. So in that case, what we do in what we did, if you remember in spam filter, is that we specify initially that these things are spam and these things are ham, and then we trained a model. So that is a supervised learning task. Okay. So as we specified, yes. So here the spam filter is trained with lots of example emails. That's training data, and each training data. So what you would start is you would start with large data set, maybe 10,000 of them, and for each 10,000 each email you would specify if that's a spam or ham, and then you would train and you would create a model out of that, and that model would finally classify new emails and say if they're spam or ham. So that's how this works. Now, what is the concept? The next concept is regression. So so the way regression changes is that what it looks at, regression tries to get a value, right? It tries to get a value. So given, like, say, age of a car or certain features of a car, give me the price. That is regression. Okay. So because I need a value out of it. If it was a simple label like good or bad, that's a classification task. But in case if I want to get a value, that's called regression. Okay, so we have some questions on that. So as we said, given a price of a car, predict the price of a car for a given set of features. So you'd given me mileage, age, brand, etc. And then what you would have to give is you would have to get a lot of examples of these cars. So get prices, get a lot of these. So what we call predictors, which are the features, which is also called features. So for example, the mileage, age, brand are predictors or features, and the price is a label. Okay. So in the other case, in terms of when we're talking about spam filter, the label is just spam or ham. That's it, and the content of the email, the sendee, the IP address from where it came, etc., the subject, etc., are the predictors. Okay, so those are the basic concepts of machine learning. That's how it happens. Okay, there is this other thing that's you've heard that you could use the data from the stock market. A lot of machine learning is used in data in stock market. So this is certain indicators that you can get from the Indian Stock Exchange. And using this information, what you could do is, so this is something I did, is that I predicted the return after 2 years. Okay, this is the return after 2 years. So these were two indicators which I would call say predictors over here. And what I did is that I put in different labels of saying that is the return after 2 years negative, that's red. Is the return after if it's greater than 20%, it's blue. So blue is nice, red is bad, and we have green and yellow in the intermediate. And so if I build an algorithm over here to predict the actual return, so the actual price, I would be using regression. But in case if I just want to predict, is this a good time to invest? Yes or no? That is a classification task. Okay. So that's like a nice difference between classification and regression. Okay, so now the next question is, so next type, we looked at supervised, which is human supervised. The next type we're going to talk about is unsupervised. So in unsupervised, the training data is unlabeled. So the system tries to learn without a teacher. And so here I'm going to give an example of a question that came earlier, which was about anomaly detection. And we'll talk about how you could use unsupervised training to do that. Okay, so what it does is you will be given a training set. So how unsupervised learning works is that you will be given a training set that looks like this, and you would want to do something like clustering. So you would try to build up features over here and make separate and distribute these people by a certain set of features and separate them. Okay, so some of the features are to detect a group of similar visitors to the blog. So the training set may be unlabeled, and you would just feed it in, and you would only figure out some sort of groups that it kind of figures in. So you would figure out that, hey, like 40% of the visitors are comic lovers and they read the blog in the evening, 20% of visitors are sci-fi lovers who read the blog on the weekend, etc., etc. So you would kind of figure out data like that. Okay, so what I'm going to talk about is I'll also show you how anomaly, at a very high level, how anomaly detection would work. So, for example, if you had like lots of data, like, okay, this is lots of data, and if you have one piece of data over here, okay, so using unsupervised learning, you would figure out, hey, this is one data set, and anything outside that is an anomaly. This is like the simplest way when we use unsupervised learning to detect an anomaly. You would put all your data and you would try to group it up. And if something just falls widely out of the group, you would say that's an outlier and probably an anomaly. One example of that could be, for example, if you're looking at credit card, it's like your credit card. Okay, so for example, you are maybe in France, okay, and you are always using credit card during what is the French day. And if suddenly your credit card gets used in, say, South of America at midnight, that's anomaly. Okay, that's an anomaly. So typically you would put data like that you would put data like that and you would try to see what falls weirdly out of it. And unsupervised learning is a great way to do that. That's how anomaly detection is done most easily. Okay. So that was, I guess, a question from Sonu Kumar, which answers that. Clear that and move ahead. Okay, so there is another form of clustering that happens. It's called hierarchical clustering. So in hierarchical clustering, what happens is you try to bring similar items together to form a tree. And one of the greatest examples is biology, where the classification of humans, of animals, of the animal kingdom, and the plant kingdom happened on that manner. And so as you can see that there are certain features that tie the different species together, and therefore the horse and the dog are kind of more close to each other. The rat and mouse are closer to each other, and you can kind of build up a relationship between that. So this is a different form of clustering. It's called hierarchical clustering, and it's also very commonly used. It's often also used while doing trying to cluster lots of types of cars together. This is also a technique that's done. Okay, okay. There's an anomaly detection. So this is what I drew before. So this is, and as I said, this is a very simple way of doing anomaly detection. Okay. Okay, there is another way where we use unsupervised learning. This is in my IoT company, Yatis, we did this. So what we did is we plotted the, so we could read, using our devices, we can read the speed in RPM from a vehicle. And what we could do is that, so when we plotted like the speed and RPM over here, we get graphs like this. Okay, and if you try to do fuel efficiency versus speed, we get graphs like this. So as you can see distinct spokes over here. You can see 5 spokes. Can anyone guess what these spokes are? Because RPM and speed, so we've got different relationships with RPM and speed, and also we have fuel efficiency on the y-axis and speed on the x-axis. What we have is that as we keep going up, we see that fuel efficiency increases, and after a speed, the fuel efficiency decreases. But we see five different relationships. Right. So Aparna got it right. It's gears. So that is gears fundamentally. So what we could do is we could use unsupervised learning and actually figure out which gear is where. And we could create a generalized algorithm which we could apply on any car, any truck, any bus, and figure out for a given, we could figure out if the vehicle was on which speed, or find out relationships like this and define what's like a good spot or good speed at which a person is driving, and also give indicators of the person is using the gears correctly. So that's like a nice example, a real life example of where unsupervised learning could be used. Okay, the next type is reinforcement learning. So reinforcement learning learns on a concept. We saw an example of reinforcement learning. The example we saw with Mario, it was an example of reinforcement learning. So what happens in reinforcement learning is that you observe, you create an action using a policy. You create the policy, you commit the action. After the action, you get a reward or a penalty. So if you get a reward, that is a positive, you update the policy accordingly. And you keep doing that till you get the most optimal policy or you get the best results. And then you know that what to do. So example, the policy could be, what do I do when I see this turtle? And there are multiple actions, and you finally find out, hey, the best policy is to jump on top of it. I get points. So that's how this thing keeps iterating. Okay, so so the machine is what we do is, again, what the agent is doing is it's observing the environment, it selects and then performs the action, gets an award or a penalty, and then figures out what's the best strategy or policy to do that. Okay. So okay, the applications. So other applications of this are used by robots that learn how to walk. There's DeepMind's AlphaGo, which defeated world champion Lee Sedol recently, and like defined computers seem to be beating people at everything. Okay, there is other concept of how machine learning is learning, is whether it's learning incrementally, and there are 2 types of learning incrementally, whether it's online or on batch processing. So what is batch learning? So in batch learning, what you have is that the data set would be very large. It would be split into smaller components and fed, and it would basically be fed into your training model step by step, one batch at a time. And you would continuously run the evaluation, analyze errors, and do it. So a great way to do is that if you have a lot of data, this is a very common technique. And well, it's an offline technique, so it is capable of learning incrementally, and it must be trained offline. And after that, you could deploy it. And every time you get more amounts of data, you need to keep the system offline, train it again, and deploy it. And yeah, so as I said, this is how it happens. So once something is deployed, it just keeps running. And if you ever have to make an update, you have to stop it and you have to retrain it and then just do it again and again. Okay, so the problem here is that we cannot train the system incrementally. You have to train the new system every time. So if you have a new data set, you have to create a new data set and do from the start. Again, you have to stop the old system and then you have to replace it with a newly trained system. Now, so if you have to train a new system every time new data is available, that is a lot of wastage of computation resources. And training every time from scratch is kind of very difficult and becomes too expensive, very slow, etc. So what really happens is that you would basically, or how an online training system would do is that you would start with, yes, a lot of old data in batches. You would train that, and then you would, while you run it, you would be running with data on the fly. So as new data comes in it, you would keep learning automatically. So this is said, this system, it learns incrementally by feeding data that comes in slowly, sequentially, and it can run data in batches, but it also can learn from new data on the fly. Some examples where that is used is again in stock prices, you create tickers that keep feeding you data into your system and that keep doing it up and up. Okay. Then there is how to use the next question is how do you basically do online training with huge data sets? Well, if you have something very large, what do? You divide and rule. That is the way you do it. You have a lot of data, you chop into small pieces, and then you feed batches to it one by one. Okay, and so why do you do online training is that basically if you have large amounts of data, you typically can't be put into one machine at one given time. That's why you break it up into small batches. And then you train each batch, you just put one batch at a time and you train it incrementally. That's how you do it. And now the problems with an online training system is that sometimes you just leave something just to run all by itself. Like, hey, it's getting new data and it's feeding. It turns out that often these systems, their performance gradually declines, they get bad. Why is that? It's typically because bad data is being fed into the system. Because hey, everything is running automatic without, if it's runs completely without human supervision, bad data gets into the system. That could come because of say a bad sensor in the entire system, or somebody actually feeding in bad information, either intentionally or unintentionally. Either ways. But what would happen is that if you leave an online system to learn all by itself, it could eventually get corrupted. Okay, so this is somebody asked what the disadvantages of machine learning. These are some advantages of machine learning. If you create a system that's supposed to work all by itself without any human supervision, it will eventually give you bad information. So all machine learning systems have to have a human supervision, some amount of human supervision. It can reduce, but it is needed. If you let it run just by itself, typically the quality of it would go down, or you would get results which you don't like, not optimal, etc. Okay. Okay, so as we said before, most machine learning tasks is about making prediction, and so having a good. So if you have good performance in training data, that's good. But what you really want is you want your model, whichever model you've now created, to work very well on new instances. So what you need is you want to create a model that's well generalized. So you don't want a model that works only on your training data. You also want it to work on any data that you get later. Okay, so that is the next important uh, type which you talk about is how do they generalize. And there you have two types: instance based and model based. Okay, so like for example, what you have is, you say an example, you have two features, feature one and feature two, and you've given it training data, which is either gray triangles or yellow squares. Okay, and then you've given this data, and then you get a new piece of data. You get this new instance over here, and you want to see how what does this become. Okay, so in instance based learning, what it's done is that you look at your instance and you just look at how distant or how close it is to your existing training data. So for in this case, for example, it look at, okay, say this x is close to uh, two, two of these triangles and just to one rectangle, and therefore this guy would say, okay, this new instance is a triangle. Okay, so that's how instance-based learning would happen. There are some, like this is learning by heart is one of the examples. Learn a lot of things by heart, and then you just, when you come up with something new, you try to find some sort of similarity, and according to that you try to classify or process that automatically. And so there are spam filters that, for example, yeah, you can have a certain, you could have a database of saying, hey, these people have marked these as spams, therefore these are spams. They are similar to non-spam emails. So that's one way of doing it. So one way of doing it is that, hey, you just have something like, you would count to say, this is just an example of a spam filter. One rule is that, hey, you have, how many, now how many characters or how many words are in spam or some sort of spam emails, and you say, if it's quite similar to that, you could say it's spam or not spam. A very simple rule. Okay. Okay, so now let's talk about the next type of it, which is model-based learning. So in a model-based learning, so for example, again, you have the same story. You have training data that's either in these rectangles or these triangles, and you would have a new instance. So what you would do in model-based learning is that you would build a model. Okay, that's how machine learning works, is that you build a model. And so the model would look at the data and say that it would kind of figure out a border, a boundary that separates the triangles from the rectangles. Okay, and if it's got an X here, okay, it would say that, okay, if it's on this side of the boundary, it's a triangle, and if it's this side of the boundary, it's a rectangle. It's not exactly how instance-based learning would work. Instance-based learning would say that, okay, this X, it's closer to two rectangles or two squares, and is close to one rectangle, one triangle, and it would specify it to be a rectangle. But whenever you're using model-based learning, it would, what training would do is it would abstract out some details and figure out a boundary, and then just use that boundary to separate it into the available classes. Okay. So now what we do for generalizing is, as we said, a model-based system is better for generalizing. And what it's done is that you build a model with all the examples, and then you use the model to do the prediction. And that step is called inference. And you usually hope that the model will generalize well. And well, this is something which we talk more in the classes. There are a lot of questions that have come. Some are, like, for example, I think some people want to learn more about dimensionality reduction, but that's covered more in my classes, not so much here. Alternatively, you could, as I said, a lot of the course content is available for free. You could just take the course for free and go through it. Okay, now we'll talk about the next type, which is called artificial neural networks. And what artificial neural networks? So what are artificial neural networks? So these are computation systems that were inspired by the biological or animal brains. So people looked at, studied, so the way it happened is people studied how brains were put together, and they tried to build similar things in programs, in software. That's how they did it. So what is done is typically is that this would be a neural network. So in a neural network, what you have is you have an input layer which has a bunch of inputs, and the outputs of so this layer is then connected to a lot of neural network, to a lot of these neurons. So these circles here are called neurons, and what are done is that the inputs of the previous stage are connected to the so if you're looking at this stage, the previous stage outputs are connected to this stage's inputs, and while connecting them, they're given some sort of weightage. Okay, and this thing is just done consecutively over and over again. So this is a neural network. So one example is that, say, for example, if you want to do a cat versus no cat predictor, so you get an image and you say, hey, does it have a cat or does it not have a cat? So in that case, say all the pixel values would be on the input, and on the output you would just have say just one output, which would be zero. So it would be zero if it's not a cat, and one if it's a cat. So it would be a one if there's a cat, and a zero if it's not a cat. Okay, so that's how typically a neural network works. This is what an ANN is. This is what neural networks are. Okay. In case there are questions, please shoot on the YouTube chat I'm watching, and I will be taking regularly answering them. Okay. So one example, a very nice example of how deep learning seems to work is we give a real example of using a knob that helps you choose the right temperature of water. So what would happen is that this a knob would be a neuron. So so normally how does this work? So you go into a hotel and you want to get the right temperature of water, and there is one knob which you need to turn. And what you would do is that you would basically start with a certain point, okay? And you would say, hey, is this, so you know that one side is too hot and one side is cold, and you need to get a right mixture of hot water and cold water to get your optimal water, what temperature you like. Okay, so how would you do that? You would go and you would open it up and start with some point, typically the midpoint, and then you would check, okay, is this good or is this what I like? Now if it's too hot, what you would do is you would turn it in one side, and if it gets hotter, you would so know that, hey, no, this is not the direction I'm supposed to go to. I'm supposed to go in the opposite direction. So then you would go in the opposite direction, and you would do this multiple times. So you maybe go to the hot direction, you say, hey, this is too hot, and then you would go towards the colder direction, and you would say, oh, maybe this is too cold, and then you would iterate and come to the best location. Alternatively, you would say, okay, I've gone hot, okay, I need to get slightly colder, so you just move it slightly. Okay, and eventually you would move it around, and you would finally figure out, hey, this is the right point for me to put the knob, and you can mark it. So very much machine learning and even neural networks work in a very similar way. You've got inputs that can do different things, and you had know that you want a particular output value, and then you would change the weightage given to these respective inputs. And this is done by the neural net neuron. It just chooses a weight between your particular inputs till you get your particular output. Once you get your output, you freeze that, and that's your final model, and that's what you deploy. Okay. Okay, so now there's a lot of often there's questions upon what are deep neural networks. So a deep neural network basically has many more hidden layers. There's more than one, anything more than one. So simple. So you say your first layer on this side is your input layer. Your last layer on your right side is your output layer, and the layers in middle which are not visible are called hidden layers. So if you have more than one hidden layer, it's a deep neural network. So that's what deep learning is. So deep learning is the art of actually making these neural networks and then training them accordingly. Okay. So now, a second. Just checking case of questions. Okay, so now who's using machine learning today? So everybody is using machine learning today. Almost everyone in this world is using machine learning. Machine learning is used by BuzzFeed to figure out what kind of articles it's to feed you. Airbnb using everybody in the world is using machine learning. So if you've heard about Google Translate, which that does translation between multiple languages, that's an example of machine learning. There is auto draw. Over here, we have given a link to AI experiments with Google. So I recommend that you guys try it. And this is a great example of how machine learning is working. That is another nice one is that for the people who want to figure out how neural networks are working, you can try the playground, the TensorFlow playground. So this is a very interesting tool. You can kind of build a machine learning neural network and run training on top of it. Some of these features are a little more advanced, but if you do a couple of classes, you would start figuring out what learning rates are, what activation functions are, what regularization is, etc. And you can build your own neural network and do that. Okay, so Ashdeep Singh asks, why would someone use machine learning instead when we have this great thing called deep learning? So deep learning works very well when you have large amounts of data. So if you have really, really large amounts of data, which can train a very large deep neural network, that's a good idea. That works very well. But if you don't have large amounts of data, then a deep neural network may not give you best results. Okay, and so that's one of the big differences. And the other thing is that if you have a simpler problem, you can use a simpler solution. So if you can have a simpler problem that can be solved with a simpler machine learning algorithm, use that. So if you have something that can be solved by a linear regression, by a single line, use a simple equation. So if you have a really large complicated problem with huge amounts of data, then you would use deep neural networks. So this question is, so he says, but there aren't simple problems in the real world. Well, there are problems that can be solved with simple equations. So in most business problems can be solved most business problems, to be very clear, can be solved with a very simple linear equation, usually fixes it. But if in case you're trying to do something really complicated, like say computer vision, etc., then you can't do that with just a machine learning model. Then you really need to go into deep learning, and that's one of the reasons why fields like computer vision and natural language processing have exploded recently. It's because of deep neural network techniques that are becoming more and more robust, and the fact that you have large amounts of data in a nice digitized format. That is the reason why you're seeing a huge explosion with computer vision and say natural language processing, and using these deep neural applications coming everywhere and impacting almost each aspect of a life. Okay, so now what are deep learning frameworks? There are like TensorFlow, Theano, Keras, Cafe, Torch. These are deep learning frameworks. In our courses we focus on TensorFlow and Keras. That's what we focus on. Typically these are the most popular ones today, and you basically just need to learn one particular type of platform. And if you learn that well, if you need to learn another platform, it's easy to do. Like for example, if you learned C, it is easy to learn Python. It's a similar thing. So you just have to learn one well, and then if you need to learn something else, you'll be able to learn it quite easily. Okay. And then there are what called machine learning frameworks. So machine learning frameworks are like Spark, MLlib, or if you want very simple ones for a single machine, then there's scikit-learn, NumPy, and Pandas. So NumPy basically handles things like arrays, and Pandas is to things like what they call data frames, which are like Excel sheets, you could say. So one of the big changes today is where computer vision, using a lot of applications of computer vision applications of deep learning is in computer vision. Computer vision is hitting almost all parts of our life, from like even simple cameras today are able to do that. If you upload photos, like if you're using Google Photos, you'll realize that it's automatically be able to classify people or detect people on photos today quite easily. And you see small, even like very simple things like there are smart cameras, very cheap smart cameras that are able to do very, very intelligent things. And AR, VR, etc., are all driven by largely computer vision. So yes, so this is like a nice holistic chart of how computer vision, various aspects of computer vision are coming together. So when you learn computer vision, it is impacted by engineering, physics, biology, psychology, computer science, and mathematics. Everything is getting put in, and at the same time, computer vision or the algorithms are impacting other fields also at the same time. So one nice little example is that there is this competition that happens, ImageNet. Okay, ImageNet. That's an image classification challenge. So what happens there are about 1,000 object classes, There are about over 1 million images, so 1.4 million images. And so images that look like this, okay, like might, as you see, it's not the end or the full might also, it's a part of it. And so a challenge ran from 2010 it ran till 2017 actually. And what happened is that, so this is like the last decade essentially. That's where deep learning and computer vision just took off and just revolutionized everything. So at the beginning of the decade, the existing system was having error rates of 28.2 percentage. Okay, not good at all. And over a period of time, it's gone over here. And it is believed that for the same data set, the humans, so the human error rate would be around 3%. So around 2015, it's got better than humans. Okay, so humans are 5.1%, and over year 2015, it got better than humans. And so I'm not saying that computers can see everything better than humans, but for this particular data set, for this particular challenge, the algorithms, the models got better than humans for this particular data case. So that's what's really happening. It's not saying that computers are generally more intelligent, but you can take a computer and train it for a particular task, a very specific task, and it can eventually do that task better than a human. It's not that all the it's not that I can take this. You like, for example, you can't take this computer vision algorithm that beat human at this image classification task, and you can't tell it to start giving out poetry. It can't do that. Okay, so it's been specifically trained for this particular task, and it can do that better. And so that's what's possible today. You can take deep learning course or a deep learning model and train it to do a task better than humans can. Okay, so I am now going to, while closing, I think I'm towards the end of it, yes. So again, this is the machine learning specialization course. You can enroll in it, and we've got 250 hours of blended training. You've got the access to the labs for 240 days. You've got, actually not 18, we have 30 plus projects today. The number of projects keep increasing. We are adding about 3 odd projects a week, and these projects will just keep increasing. And if you take the course, you will get access to the project. We've got automated assessments and quizzes. You get lifetime access to the course content with a certificate, and you get support to answer the questions and queries at all times. These are instructor-led training, so there is a very regular interaction with an instructor, which will start on the weekends, where you can do that. Okay. Okay. And now I'm basically open to questions. So there are certain questions open now, and I will go through them. And at the same time, I will, in case you have more questions, you can also reach us out in a discussion forum where you can interact with us and often as students, and also reach to us clearly by just writing us an email at reachus@cloudxlab.com. So now I'm just going to ask some questions. So there's some questions. The Enver has asked a question. I'm totally fresh. Is it possible for me to learn ML and DL and find a job after completing CloudxLab training? Enver, the answer is correct. Yes, you can. So people don't. So we've got again. We can train people all the way from Python till you can learn very advanced things like reinforcement learning. In the meanwhile, you learn computer vision, etc. So it's a huge field, and you can learn enough to get a job as a data scientist or a machine learning engineer completing a course at CloudxLab. That's definitely possible. Ashdeep Singh asks, what are the projects that are taught in this course? Yeah, so we have, so what I would say is that you can go to our course page. I think I have to share. Give me a second. Yeah, I think I have to share my entire screen for that. Okay, so the courses, so you can just go online to CloudxLab.projects and you can look at other projects. Okay. So as I said, there are about 30 plus projects. There are projects that talk about churning email inboxes, which is again something called spam learning. There's an example of how to forecast bike rentals. This is data about multiple multiple features or predictors like wind speed, temperature, etc. that are given, and you're supposed to predict how many people will come to get bikes. This one is about building about classification. So it's a computer vision one. This one is a classic one. It's called predicting Titanic passenger survival. So you give in a bunch of metadata about different passengers, and you have to predict which passenger survived and which passenger didn't. This is not a practical. This one building cat versus non-cat is not a practical one, but it's a very interesting exercise where we build an entire a complete neural network and do classification with just using NumPy and not using any advanced advanced packages like TensorFlow, etc. And there are multiple like these. You can go to the last one, and like these are proper computer vision tasks to how to detect it. These ones tell you how to actually deploy a model on a system. So actually deploying a model on a system, which is really real world problem. A very advanced, fairly advanced real world problem is that you make a computer vision, you make a model. How do you deploy it so that people can access it easily? That we do that. This one is about noise filtering. This actually uses unsupervised learning to do it. So we have a lot of these ones, and you can take a look at it. So, and a lot of these are real life problems or teach you very relevant skills. Okay, I strongly suggest all of you take a look at it. Take a look at cloudxlab.com/projects, and you can see everything over there. Okay. So okay, so Ajdeep Singh is, so you want a DLML project that's integrated a beautiful website. So not a beautiful website, but these ones will give you a basic website to work with. Okay, so this one is also it builds what's called a Flask. Flask is a framework for making web applications with Python. So in this, you'll actually make a web app with a decent. It's not a very beautiful one, but it's a functional web application which with a machine learning model in the backend, where you can feed an image and it would give you an output. Okay. Okay. So Ashley Psico also asked, do you teach full stack data sciences? Yes, we teach full stack data sciences. Please go ahead and look at our courses. And you have a course called Data Science Specialization, which goes through the full stack of data sciences and will teach you almost everything you need in the data science field. Please take a look at it. So beyond machine learning, it even talks about big data exercises, etc. So you get that it. So Anish asks, how many hours per week has to be dedicated to learn machine learning to be well placed in this? Well, Anish, I would say the right answer for that would be around, I would say 16 hours. So the weekend, 8 hours each week, the weekend should be sufficient. So 16 hours a week should be sufficient for you to learn and be on a good pace. Okay. Anubhav Gupta asks, for job interviews, is it necessary to have complete knowledge of code or having theoretical knowledge about how the model works is sufficient? Anubhav, it really depends on the job, but typically the jobs would require you to solve a real problem. So your capabilities to actually code is important because typically, I'm saying most of the jobs would require you to actually solve a problem, and you will not be able to. I'm talking about machine learning, more advanced things. You will not be able to solve a problem without coding. Okay, and to be a really good machine learning engineer, you will have to learn to code. That I would say is more important than understanding all the mathematics behind it. Say if you want to be a professor, or like for example, a teacher in a university, I would say that yes, it's possible. Yes, you need to have the theoretical knowledge. Theoretical knowledge is more important than practical knowledge. But for a job, coding is more important than knowing the uh, exact theory behind what runs a model. The what is more important is how can you solve a problem, and for that you really need to be adept at coding or reasonably comfortable with coding. Okay. Naveen Dinakaran asks, I'm a PG final year student. I'm interested in computer vision project. And before I do project, where to start? What should I learn? And what do I need to learn to achieve CV project? So, Naveen, so we have a course on computer vision, which covers OpenCV, which is the most popular tool for computer vision, and then the deep neural, and also how to do computer vision with deep neural networks. We have a course. It's called, it's going to be called. I'll just say. Give me a second. Sorry, not over here. So you go to explore courses and you can just write computer vision. I think it comes up. Give me a second. Give me a second. Yeah, right. So it's over here. So the course called Computer Vision. So the self-paced course is available for free, and you can just start with that. If it also includes components of Unix and Linux and Python in case you're not comfortable with it, or you can directly jump to the computer vision component, which would first cover OpenCV and then deep neural networks and how to use deep neural networks to solve computer vision. And then we also have a lot of projects for you to really apply your skills on. Okay. Saurabh Mishra asks, so I've joined this class. I want to know what we covered in the next 2 to 3 classes. So Saurabh, so the next so we're not running live classes for the next 3 weeks. We'll be running it after a 1 month. So for right now, I would say that go ahead with the with Python and Unix Linux components. And in case you have any doubts, please reach out with us. I think we've sent an email a little earlier that the course has been pushed out a little, but it doesn't stop you from starting on it yourself and at the same time reaching out to us. And for in case of any specific doubts, we will solve it. Okay. So again, there's a question of how much time should we be spending per hour on the per week on the course. I would say about 16 hours should be sufficient, 8 hours for the weekend. So how do I start a journey as an applied AI scientist? It again depends on where you are. If you know Python, one of the great places I'd say is again you start with the if you're comfortable with Unix and Python, you can bypass that. But I'll start with Linux, Python. Then you would start with machine learning, and then go on to deep learning. That is the path which we recommend, and we have you could. So if you directly want to go, so I'd say the machine learning specialization is a great course to learn to become an applied AI scientist. The machine learning specialization is the best course, and as I said, what it starts with Python for machine learning, but there's a Linux component, machine learning, and then deep learning. That is what we recommend. Okay, and we do projects. So actually, AI, ML, and DL. What are the concepts? So AI is a very generic. Saurabh so Saurabh, yes, the course should start in February. We were planning to start, but the current courses have taken a little longer, so we have like pushed out the starting date a little. But again, that doesn't stop you have access to all the content, and we are giving you the lab. We are giving as a token. We are actually giving the lab for 2 more months. So you should start using the lab also simultaneously, and start going through the courses by yourself. And please, again, as I said, to reach out in case of any doubts. So Arshdeep saying, so AI, ML, and DL. I'm confused with these three terms. So, so artificial intelligence is a much larger field, okay, and machine and is a much larger field. It's about, again, getting computers to take the data and doing something based on it, and a lot of it doesn't require machine learning or deep learning. Now, machine learning is, again, as we had specified before, it basically is kind of you're trying to build a model with all the existing data. That is what you're trying to do. You're trying to build a model. And just try to also go back to the slides. Go slide on that. Right. So artificial intelligence is like the whole thing together. Uh, what you're talking about, so artificial intelligence is much larger. It's just not just machine learning or deep learning. You could do artificial intelligence without machine learning, without deep learning, with simple simple software, simple rule-based programming. You can do that, like the classical spam filter. It's just that today we know much better ways of doing it. So in machine learning, what we do is that so in machine learning, the idea of machine learning is that you take data, you study that data, and you try to get some ideas out of it. And then now, once you've kind of made a model of that, you've taken code, you've let it run on top of it, and it has figured something out. That model then can be used in a lot of other places. That is the idea of machine learning. What is deep learning? Deep learning is when you do machine learning with neural networks. Okay, when you do that with neural networks, so that is as I mentioned. So when you use actually what is it, deep neural networks or deep neural networks, that is when it's called deep learning. Okay, so like for example, if you have a lot of data and you actually just put it towards y is equal to mx plus c, and you're able to do a model, even that is machine learning to an extent. That's like the simplest form of machine learning, is taking just simple data and putting it to y is equal to mx plus c, which I gave an example where I said price of a car versus age of a car. You just have a lot of data of different ages of a car, and you have price of the car, and then you build a simple relationship between price of a car and age of the car. That can be done with machine learning tools called linear regression, and that's also machine learning. And if you do something complicated with, say, neural networks, which typically you need to do if you have to solve a problem like computer vision, trying to create or do a natural language processing problem, then you need something like deep learning. So fundamentally, deep learning is a part of machine learning, okay, which in turn is a part of artificial intelligence. So if many coders and persons create a machine learning model and say they've created an AI. Well, it is. So AI is inclusive. So yes, so they're actually correct. They have created AI in a certain method. They have created AI in a certain way, a certain part of AI. And there are a lot of different ways of creating AI. So AI is just much larger. There are many ways of implementing an AI system. And machine, just that deep learning today is like the most newest way and the most very powerful way of implementing artificial intelligence. The Naveen asks how much math and statistics are needed to do a CV project. Naveen, so again, as I keep saying, that you need coding and you need to understand fairly basic mathematics to do actually implement an computer vision project. or you what the math is roughly needed to understand what is happening roughly. So you kind of eventually you have to have, so if you have like zero mathematical background, like absolutely zero, then it will be difficult for you to understand. But what you really need to do is you need to get an intuitive understanding as what is happening behind the algorithms. So that as we said, if you were coding in like 1970s or early 1980s, you would have to be a postdoctoral guy, or a very exclusive guy to be doing coding. But now we know that even 6-year-olds can code today. That is what we've learned. It's because we've made it easier and easier. And the same thing is happening for machine learning. There are a lot of ready-made algorithms which you could just run out of the box and implement a computer vision project. And so if you want to be, but again, I have to be honest, if you want to be very good at something, or like have deep understanding, then you will have to get into the mathematics. But to be applied one, you really don't need to understand a lot of mathematics. You just need to have enough math background to understand or get a gist of what is happening. Okay. Pradeep Sharma says experience ETL would be useful, ML and DL. Yes, so any kind of experience with playing around with large amounts of data is very useful for doing machine learning and deep learning. So I would say yes, if you have experience in ETL tools, that would definitely help you. Asynchronous programming, meta classes for data science, is any related thing to coding? And so we need fairly simple amounts of coding to do this, Ashdeep. You don't have to go to asynchronous programming, etc., for the basics of it. Okay, fine, folks. Any more questions? So again, in case of questions, do reach us out. We could alternatively. So my name is, I think my name and my name is definitely here. I think my LinkedIn address is here. In case of any questions, you can connect to me on LinkedIn. Otherwise, for a really quick response, just send an email to reachus@cloudxlab.com. Just show the address again. We've given up a form, a registration form. So if you fill the registration form, we will send you the slides, the slides that were presented today. At the same time, this particular lecture will go live on this YouTube lecture. So if you want to revisit in the past, you can do that. Okay, fine. Okay, so the last question is about reinforcement learning. So actually, it's a question of, can reinforcement learning solve all problems? So actually, I think fundamental thing you should realize is that you want to use the simplest of tools to solve the simplest of problems. So wherever you can solve a problem with something simple, say for example, if you for example, if you're using reinforcement learning for yes, you need reinforcement learning if you're solving Mario, but you also need to implement computer vision algorithms first to figure out what is happening. Okay, so if you're trying to just implement computer vision, trying to figure out in this picture if there is a horse in this picture, you don't need to have reinforcement learning to do that. You just need computer vision. So that's the way it is. So yeah, so there's a question. Rahul says that's very important that we don't see neural networks as black boxes. That is correct, Rahul. We don't. So again, so we go very deep into how deep neural networks work in the class, and we do it very simply by, again, as I said, by not making it very complicated, by using simple mathematics. So you and that is done during in our classes. We do that. We actually show you. So as in the high level, you've shown us what a neural network is, and in the class we actually use very simple mathematical exercises to actually show how the whole thing is built and how the whole thing is trained. So normally the whole training exercise of a deep neural network is considered to be mathematically very difficult to explain, but we figure out very simple techniques of doing that. So again, this course, what I showed you today is just an introduction to AI. The actual course is just a lot more deeper. We go much deeper into the theory of it. We just try to keep the math as use most simplest math possible. That's all. Okay. So again, there are a lot of questions which are very specific, deeper into the course, which I would say that again, as I said, a lot of it is covered in the course. It's also covered, at least content-wise, it's also available in the free course, and you can just take a look at it. So Ashdeep saying high accuracy on test set and less on training set. High accuracy on test set and less on data set. Is it good? Does it happen with me? And I saw most problems with it. So Ashdeep, having high accuracy on test set and less on training set is kind of weird. Typically, what most people see um, is higher on training set and lesser on test set. So if you've seen higher on test set and lesser on training set, still it's good, but it's kind of weird, and that's not usually normal, though. Okay. Fine. So again, for specific questions like in reinforcement learning, I say please go to the content that is beyond what we are discussing today. Okay. 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 This is the last question I'm taking. It's about the PyTest module. Again, so unit test is not really a critical part of machine learning. So we don't really cover that in this course. That's used for testing, etc. And yes, you can use it for testing anything, so including machine learning. But that's not we don't really cover PyTest in this course. Okay. Okay, guys. Thank you for your time. I really enjoyed talking with you guys. In case of question, uh, okay, last question. So when does outlier matter over data points? Well, one great place where outliers matter is when you're doing anomaly detection. That's where outliers are most important because that's the entire exercise of it. But that's where it's most important. Uh, so that in anomaly detections where where normally outliers are most important. Typically in machine learning processes, you try to reduce outliers to reduce the amount of noise, and you accept to keep that as an acceptable form of error. Okay. Okay, guys. Thank you. Have a good night or good evening based on your location, and or a good day. And I hope to be in touch with you guys later. Thank you.